All right, here is the first example to follow along with and jot some notes on how to use this definition of a derivative to find the derivative of this function x squared. So I do a quick graph over here. It's just a parabola. And so y, again, is the same as f of x. So really this y equals x squared is the same as saying f of x equals x squared. So again, when I come over here to talk about f of x, I guess maybe I'll put that over here on the other side instead. That equals f of x. So again, this is going to be a long process. This works for every single and any single function and how you can find the derivative. And it's because the derivative function gives you the ability to find the slope at a tangent point anywhere on a curve. So that's why we're doing it with the function. Now, after we do this a little bit, we are going to look at a much quicker mode of finding the derivative. We'll look for some patterns that happen when we do this. And so you don't have to spend a ton of time doing this the rest of the year, so don't worry about that. Secondly, this may show up on an IB exam. I've seen it, not all the time, but every once in a while. So it is something we need to be aware of, and it may show up, but generally when they ask you to find a derivative, we won't be using this after we kind of see how it works and why it works. So the first thing I'm going to do is I'm always going to write this down until I've actually finished doing the limit process. And the limit process means at the end, I'm going to put 0 in for h. Now when I put 0 in for h is gone, and I found the function that gives me the slope at any point on the curve. But I can't plug it in right now because we already talked about that in the other video. That would give me 0 on the top and 0 on the bottom. So I have to do some algebraic manipulation. And what happens is every time you do this, this h on the bottom will cancel. So you kind of know you've done it right if you get to a point where there's no more h on the bottom, because that's really the problem, is dividing by 0. So that's why we've got to do some algebraic manipulation to get rid of that. So the first thing I'm going to do is I'm going to figure out what this equals. And f of x plus h just means I'm going to plug x plus h into my function. So I'm going to plug x plus h right here. Just like if I asked you what f of 2 was, you would take the 2 and you would plug it in here and you would square it. So you would tell me it is equal to 4. Well, I want to know what x plus h is when I square it. So this first function is going to be the quantity x plus h squared. And that's where our algebra is going to come into play. The second thing I'm going to do is I'm going to subtract f of x. So I'm going to subtract. And f of x is just x squared. That's what f of x equals. So I'm going to subtract x squared. And on the bottom, I have the h. And remember, my goal is to get rid of this h. So the next thing I'm going to do is I'm going to keep writing this limit as h approaches 0 until I've actually plugged that 0 in for h. And now I've got to square x plus h. That means I have to FOIL it. That means I have to either take the time to write this out as x plus h times x plus h, FOIL it out and combine like terms. You maybe have done this enough that you kind of know how a squared binomial ends up. But if I square x plus h, I get x squared plus 2xh plus h squared. And that's if I just FOIL this thing out. That's what I'll get. You can check that out if you want, and if you don't believe me. So that's the stuff in red. I should have kept it in red. This is all the parentheses in red. I'll switch to blue. So then the only other part of this is minus x squared. And that all is over top of h. So now things are kind of cleaning up for me. I've done the algebra. I've squared that. Now I have a couple things that I can do up here. I've got x squared in the front and minus x squared in the back. Well, anything taken away from itself is just 0. So I now have the limit as h approaches 0. And what I have up here is 2xh plus h squared. That's all that's left on the top. So what I can do with that is notice that there's an h in both terms. So I'm going to factor out. This is why we've told you all along that factoring out GCFs is very important. This is where it starts to pay off. So that would leave me 2x plus h in parentheses. So again, that business in red is simplified of this box. I have an h in both terms. I factor it out. And I still have this h on the bottom, but I don't want that h on the bottom. That's my whole goal, somehow to figure out how to get rid of that. But look, h over h. So anything divided by itself, other than 0, is 1. So that is canceled. And so now I have the limit as h approaches 0, and all that's left is 2x plus h. So now I'm at the very end, and I am going to do the limit, and all the limit tells you to do is put this number in for that letter, because I want h to approach 0. So if h approaches 0 and equals 0, then this whole thing, as h gets to 0, approaches 2x. This is your derivative function. This function will tell you the slope at any point on this particular curve. And so a little notation that goes with that is, I will use function notation again, but when I want to talk about it in terms of the derivative, that's when I put that little dash up there. Or we could say dy over dx. And we'll talk more about that notation. But what that tells me now is if I want to know the slope of the tangent line right here at x equals 2, what is the slope right there? Well, I can just come down here and find the derivative at that particular point. So that's where I plug an x value into the derivative function. If I put a 2 in here, it would be 2 times 2, it would equal 4. And that is a very steep line. And if I want to check the derivative right here at x equals 0 at the vertex, at that turning point, if I plug in 0 into my derivative, which is right here, this is my derivative function. So at the x value of 0 on the parabola, I put a 0 in there, it equals 0. So it's the slope of the tangent line here is 0, which is right because it's a perfectly horizontal line. All right, there you go. That's your first example. And we have one more to go. Well, actually, you're supposed to try one now. It is also a quadratic. So don't forget about this little trick right here when you square. All right.